right, solving radical equations. So be careful of your types of roots, square roots versus cube roots. Even roots, you got to double check to make sure your solutions work. Odd roots, you're fine, you can just keep on going. So there's some examples in here, read through those. I'm going to go ahead down to the additional examples to work through them. So there's your steps for solving your radical equations. All right, so let's get going. So first one, make sure you know what type of equation you're dealing with. If it is an even root, you need to check your solutions for validity to make sure that they result in a true equation and not a false equation. So this is a square root, so that means we are going to have to check. So I'm going to go ahead and write check next to it so that I don't forget. When it's odd, you don't have to. That doesn't look very good. But when it's even, you do. All right. So to solve a square root equation, what you want to do is isolate the square root. So that means you need the square root completely by itself on one side. We already have that. So what we're going to do is we're going to square both sides. So we've got our equation 2x minus 3. We're going to square the right and the left sides. All right. The square undoes the square root so that the radicand, which is all the stuff underneath the square root, comes out. And then on the other side, 4 squared, 16. And in this case, we're down to a linear equation, so we just need to get x by itself. So we're going to add 3 to both sides. So we have 2x equals 19. And then we're going to divide by 2. So we get x equals 19 halves. All right, this was an even root, so we need to check it. So I'm going to go back to my original equation, which was 2, and then where the x is, I'm plugging in 19 halves minus 3 under a square root equals 4. We're just trying to make sure it's true. All right, 2 times 19 over 2 is 19. 19 minus 3 is 16. The square root of 16 is 4. We got 4 equals 4. That means this solution is valid, so we're okay to keep it. All right, next one. Oh. I love how my iPad does this sometimes. It just likes to erase stuff. It's there. I just got to find it. All right, let's go back. Let me open a new set, go back, and then we'll open it and it should pop in. Look at that. It's weird sometimes. All right, next one. All right, this is also a square root equation, so we are going to have to check it. So I'm going to go ahead and get it labeled to check. All right, I need the square root completely by itself. So there's an extra minus 4 that is not under that square root, so we're going to add it to both sides. So we have the square root of 3x equals 10. Now that it's isolated, we're going to square both sides. So I'm going to square the entire left side and the right side. Square root removes the square, or the square removes the square root. So 3x equals 10 squared, 100. Divide our 3 off. 100 does not divide nicely by 3, so we're going to leave it alone. So x equals 100 over 3. We got to check it. Anytime it's an even root, we got to check. So I'm going to go get my equation. 3, plug in x. That was under a square root. I think it was minus 4. Yeah, minus 4 equals 6. All right, 3 times 100 over 3 is 100. Square root of 100 is 10. 10 minus 4 is 6. So we're good. As long as it's true, we can keep it. If it's false, it's an extraneous solution, which means we exclude it, so there would be no solution. All right, C. All right, C is an odd root. It is a cube root. So what that means is cube roots have all real number solutions. So we don't need to worry about checking because that's an odd root. So the cube root, it's still the same idea in solving. It's already isolated. We don't need to move anything around. So what we're going to do immediately is we're going to cube both sides. Don't accidentally square it. Make sure you cube it. All right, so the cube undoes the cube root. So it's the same idea as squaring a square root. 2 to the third power. Careful, it's not 6, it's 8. Then we're going to move our 5. And we get x equals 3. Like I said, all solutions for cube roots are valid. So you can check to make sure you did your algebra right, but you don't have to check for extraneous solutions. D. All right, it's also a cube root, so no need to check. All right, start by moving the 8 over since it is not up under the cube root. You got to get it completely isolated. Five minus 8 is -3. Then we're going to cube both sides. Cube removes the cube root, so 6x plus 9 comes out. -3 cubed is -27. Remember, odd power, keep the negative. Even power, drop the negative. Move our 9 over. We get 6x equals -36. Divide our 6 off. And we get x equals -6. All right, E. This is a square root, so we got to check. All right, first thing, I need to move that -1 over. So we're going to add 1 to both sides. Difference with this problem is there is also a variable outside of that square root. So we're going to have to change our steps just a little bit for this one. All right, at this point, we could move that 3, but the problem with moving that 3 is it's going to create a fraction. So I would probably just go ahead and leave it there so that I don't have to worry about it. So right now, I am going to go ahead and square both sides. All right, squaring both sides, that does allow, just be careful with that exponent too. Exponents can be distributed on multiplication, so that is actually going to give us 3 squared times the square root of x minus 1 squared. So each of those are going to get their own square. On the other side, do not distribute the exponent. You cannot distribute an exponent along addition or subtraction. So instead, it might be helpful, instead of writing it this way, x plus 1 quantity squared means multiply it by itself twice. So we're going to have to FOIL. All right, 3 squared is 9. And then the x minus 1, the square undoes that square root. So it comes out of the square root. On the other side, we do FOIL, first outside, inside, last. So we're going to get x squared plus x plus another x. So I'm going to go ahead and combine those to 2x plus 1. All right, we have x squareds and singular x's. So we need to get everything onto one side. So I need to distribute my 9. That's 9x minus 9 equals x squared plus 2x plus 1. Move everything to one side. So the x squared is already positive, so that means I want to move the 9x over to the right, and I want to move the 9 also over to the right. So we want it set equal to 0. So we have x squared, and then 2 minus 9 is -7x, and then 9 plus 1 is 10. All right, factoring. Leading coefficient's a 1, so double bubble it. Multiply to positive 10, but add to -7. So multiplying to a positive 10, that's 5 and 2. To get to -7, a double negative. Remember, a double negative is a positive. All right, each to 0. So x minus 5 could be 0, or x minus 2 could be 0. So then we add 5. I'm running out of room. And then we add 2. So x equals 5 or x equals 2. But remember, this was a square root equation, so we do have to check these. Okay, so I'm going to put my label back here. All right, so we're going to go get the equation. Let's see, go get the original equation. So 3 times the square root of x minus 1. So 3 square root of, instead of x, remember we're plugging in 5, minus 1. I got to go get the rest of it. Minus 1 equals 5. So this is what we're checking. And you know, I'm going to kind of scooch it over here just a little bit. All right, so I'm going to check this one first. 5 minus 1 is 4. The square root of 4 is 2. 3 times 2 is 6. 6 minus 1 is 5. So this one is valid. Okay, so we know we've got 1. Now I got to go check my other one. And I'm going to put the check here. All right, so 3 times 2 minus 1 under a square root minus 1 equals 2. All right, 3. Let me make sure I copy that down right. 3x minus 1 equals 2. Okay. All right, 2 minus 1 is 1. The square root of 1 is 1. All right, 3 times 1 is 3, minus 1, 2. All right, they are both valid, so we do keep both answers here. Sometimes you'll keep one and not one. Sometimes you'll keep both. It can be a variety of combinations, but make sure you check them when they're square roots. All right, next one. Also a square root, so we got to check. All right, square root's already by itself, so I'm going to go immediately to squaring both sides. Once again, do not distribute that exponent. So x plus 5 comes out of the square root since the square takes the square root off. On the other side, foiling x minus 1 times x minus 1. So I wrote it out on the last one. I'm just going to go straight to what it is, x squared minus 2x plus 1. And if you need to go write x minus 1 times x minus 1 and go through the FOIL process, do so. So this is still a squared equation like the last one, so everything to one side. So I'm going to move the x to the right and the 5 to the right. So we're going to get 0 equals x squared minus 3x minus 4. Double bubble it. Multiply to 4. Add to 3. Negative 3. So negative 3, a lot of times we try 2 and 2, but be careful. 2 and 2's could give you 0. So I need a negative 4 and a positive 1 to get to negative 3. Split them. All right, add 4. Subtract 1. And check. All right. Back up here, x plus 5 under square root x minus 1. All right, 4 plus 5 under square root minus 1 equals x minus 1, 4 minus 1. Oops. All right, 4 plus 5 is 9. The square root of 9 is 3. 4 minus 1, 3. Let's see. To plug it in, 4, 5. Oh, nope, I lied. There's no minus 1 right there. It's on the other side. Helps if you write it correctly. So 4 plus 5 is 9. Square root of 9 is 3. 4 minus 1 is 3. So this one checks. Let's scooch it on that side. All right, second one, checking negative 1. So we're going to do negative 1 plus 5 equals, and then I think it was x minus 1, so negative 1 minus 1. All right, negative 1 plus 5 is 4. Square root of 4 is 2. Negative 1 minus 1 is negative 2. This one does not check. That is not true. This is an extraneous solution. It is a solution that is not valid. So the only solution we will be keeping is x equals 4. So be really careful. You've got to check those square roots. Let me go this way so I don't get the work mixed up. All right, next. Whoa, that is a thick line. All right. This one's also a square root. So this time we have 2 square roots, one on each side. There's really nothing we can do to move stuff around since they are on both sides. Anytime you've got multiple square roots, one of them needs to be by itself. Technically, they're both by themselves, but as long as one is by itself, go ahead and square both sides. So we're immediately, well, let me write my check. Since they're square root equations, immediately square. So I'm going to go square the entire left and the entire right away. All right, square removes the square root, so 3y plus 1 equals, same on the other side, 2y plus 6. All right, I need to get my y's on one side, so I'm going to subtract 2y. I want the numbers to go the opposite way, so I'm going to do it at the same time. So I'm going to move the 1 to the other side. So variables one side, constants opposite. So the 1's are gone and the 2y's are gone. 3 minus 2 is 1, y. 6 minus 1, 5. Again, square root equation. All right, so it was 3y plus 1, so 3 times 5 plus 1 equals, oh, I should be doing this in pink because I'm checking. Try to keep it consistent. Other side was 2y plus 6, so 2 times 5 plus 6. All right, 15 plus 1, 16. 2 times 5, 10 plus 6, 16. Well, we can go one more step, but clearly the square root of 16 is going to equal the square root of 16. So our solution is valid. Right. Next. All right, this one we have lots of square roots going on. So it's still a square root equation, so we are going to have to check. So first thing, we need one square root isolated. Also, it's important to catch. I need to do this basic math first. The less complicated it can be, the better. So 3 and negative 1 can be combined. 3 plus a negative 1 is 2. All right. Oops, not squared. What am I doing? Square rooted. All right, we have one square root by itself. We can't get both because of that addition right there, so we're immediately going to go and we're squaring both sides right now. All right, on this left side, you cannot distribute that square because there is a plus sign here. So instead, we need to think FOIL. So I'm going to write this one out because it is a little more complicated. Square root, no. So 2 times the square root of x minus 6, and then another 2 plus, and then the square root of x minus 6. And then on the right side, the square undoes the square root, so it's just x plus 9. Now that x plus 9 is just going to follow us down while we're foiling. So we're doing FOIL, first outside, inside, last. So first is 2 times 2, which is 4. Outside, 2 times the square root. That 2 just goes in front of the square root. And we go inside. Notice it's going to be the same thing. 2 just goes in front of that square root. And then last, notice they're the same. It's going to be the square root of x minus 6 times itself, or squared. All right, combining like terms, the 4, there's nothing I can do with that 4, so I'm just going to bring it down. Notice we have 2 like terms right here. I have the same square root attached, so it means I can add the numbers in front. So we can just take the positive 2 and add it to the other positive 2, so we have 4 times the square root of x minus 6. And then that last term, the square root and the square undo one another, so the x minus 6 comes out. I can combine the negative 6 with the 4. The order things get written in doesn't matter. I'm going to keep the square root on the front. So we've got 4 times the square root of x minus 6 plus x, and then 4 minus 6 is negative 2 equals x plus 9. All right, so this is the first time we've seen 2 square roots where they don't disappear immediately. So now we're just going to start that process over. I need to get the square root, the addition, subtraction, all to the opposite side. So I am going to subtract the x because I need to get it on the opposite side of the square root, and I am going to add the 2. So that's going to get the 4 times the square root by itself equals the x's disappear. So x minus x is 0. They're gone. 9 plus 2 is 11. All right, at this point, you can move the 4 if you want to, but that is going to create a fraction. So I recommend just leave it unless you're comfortable with the fraction. So I'm going to go ahead and square both sides. Remember, distribute along multiplication, and right there, that is being multiplied. So that is going to give us 4 squared times the square root of x minus 6 squared. And then 11 squared, 121. All right, 4 squared is 16. Whoa. square root becomes the x minus 6. All right, at this point, you can either distribute the 16 or divide it off. It's got to go to the other side anyways, so I would probably go ahead and divide it off. So I'm going to divide both sides by 16 right away just to get it out of there. So we have x minus 6 equals 121 over 16. Again, if things reduce them, and it does not, so we just get this lovely fraction, 121 over 16. And then we add 6 to both sides. So we're going to add 6 to that wonderful fraction. Use your fraction template. So we get x equals 217 over 16. Way back up here is the beginning of this problem. I'm going to shrink to make it actually, yeah, we're going to. I'm going to copy this over here. Sorry, I'm trying to make it neat for you in case you need to look back at it, and then we went up there. Oh, that's fun. I don't want you to update right now, but thank you. All right, so we have to check. All right, 3 plus the square root x minus 6. So 3 plus x minus 6 under the square root. You got to copy it exactly. Minus 1 equals something. X plus 9 under square root. 217 over 16. Minus 9, I think. No, plus 9. Plus 9. Okay. So, handy dandy little calculator. So we've got our 217 over 16. We're taking 6 away. I'm starting on the left. Then we are going to square root that. That's going to give us 11 over 4. We are taking 3 plus that minus 1. So if we use our calculator, that's going to give us 19 over 4. I go to my other side, 217 over 16. We add 9 to it, and then we square root that, and we get 19 over 4. That's great. So we do get the same thing, which means it is a valid answer. So we can keep it. You hate to do all this work and forget to check, and then it winds up being extraneous. So always remember to check your answer. Let me get this off there, because when I save it, it's going to shrink. There. We'll go like this. Should be able to squeeze that one in there. Okay. Next one. All right, multiple square roots here. So again, when solving square root equations with multiple square roots, you need one of them completely by itself. It doesn't matter which, but to me, the easiest one is this back one's being subtracted, so I'm going to add it to both sides. So again, square roots, we got to check. So I am going to add, you can't add them in different pieces. You have to add the whole square root on its own. So we're going to add that to both sides. Handwriting's getting terrible. All right, so we have 2 times the square root of x minus 1 equals the square root of 3x minus 1. So we want it by itself. 1 is by itself, so we're going to go square both sides. Left side, remember that exponent, that 2 goes to the 2, so it's actually going to be 2 squared times the square root of x minus 1 squared. On the right side, the 3x minus 1 is coming out. 2 squared is 4. The square root squared takes out the x minus 1. So we're here. All right, difference with this one from the last one is we do have x's on both sides. So I'm going to distribute the 4 because I got to get the x's together anyway. So that's going to give us 4x minus 4 equals 3x minus 1. I'm going to add the 4. And at the same time, I'm going to move the 3x. If you want to do them in separate steps, you can, but it's fine to do them together. 4 minus 3 is 1x. 4's are gone. 3x's are gone, so equals negative 1 plus 4 is 3. And then we got to check. So 2, and then the square root x minus 1, I think it was minus 3x minus 1 equals 0. Maybe, did I write that down right? 2x minus 1 minus 3 times 3 minus 1. Yes. All right, so we've got 3 minus 1 is 2. Minus 3 times 3 is 9. Minus 1 is 8. So in this case, you got to be careful because we can't continue the math here as written. So at this point, we either go to the calculator and type this in to see if it's 0, or you reduce your square root on your own, completely up to you. So the square root of 8, remember we're looking for perfect square factors, is 4 times 2. And then the square root of 4 is a nice number. We're allowed to take that out. That is 2. So we have 2 square root of 2 minus 2 square root of 2. Once the numbers under the square root match, we can combine the coefficients. So now I can do 2 minus 2, which is 0. 0 square root of 2 is 0. So it does check. You just have to be a little more creative on the check. I'm going to shrink that down because if it's in the margin, it will disappear. So there we go. Much better. All right. There are some you try it's below if you would like to try some and compare them with the completed notes.